Hey viewers, Alan here. Thanks for joining me in the workshop again. So in this video I've finally resolved something that's been bugging me for quite a while, which is how to trigger spark for this engine. I've known that Greg's design assumes the use of a Hall effect sensor, but I didn't have any detailed drawings for that. Quite late in the piece, Greg gave me a recommendation for a fairly generic approach using a Hall effect sensor, but by that stage I'd already bought a CDI kit, ignition kit, which included a Hall effect sensor, so I really wanted to use that. So I decided to go my own way here and set the Hall effect sensor at the rear of the camshaft, which was quite a business, as you'll see. So let's get into it, and there was quite a bit of machining. To extend the camshaft, I've machined up a 5mm stub shaft, shall we call it, and it needs to be let into the end of the camshaft about 20mm. So obviously I want to try and get this thing mounted in the lathe with as much concentricity as I can get, and I would have put it in the 4-jaw from the lathe, but that won't go small enough to hold this, so I've borrowed the 4-jaw from the Hercus. But having a look at the run out that I've managed to dial it in for, on the journal that it's currently on is pretty good. Probably got not quite 0.01, something like that. If I go over right to the end of the camshaft, there, say, just re-zero it for people who like to see zeros. And here we've got about the same, maybe slightly more, I'm not sure, but at 0.01 or less than half a thou. That's as good as I'm going to get it, I think. And keep in mind that on the extension on this shaft, the only thing that will be on there is the timing disc. There's no coaxial bearing or anything like that, so provided the timing disc runs somewhere near true, because the reader head won't touch it, it'll just be turning in space, I'm pretty sure that'll be good enough. In any case, it's the best I can do, so if it doesn't work I'll just be making a new camshaft. I'll drill a 4mm hole and then use the boring bar to open it out to 5. Now I don't know what this thing's speed rated for, but I know it's a lot less than everything else. So I've got the speed turned down to 500 or so. Right, well, let's see how that works out for me. Well, that's through to 20. Okay, so I've got a small boring bar set up here. Unfortunately, the shank is 4mm diameter, and it's been ground from that, so the cutting point is set back from the 4. So, and I need to get it in pretty much up to here. So I've got the bar set at a slight angle, and I'm hoping it'll just fit. So I'm going to have to do my first cut at 4.5, I think. So my 4mm drill left me with a 4.16 diameter hole. So let's just set the DRO. Then we take our first pass at 4.3. Alright, well that took next to nothing out, we're still on 4.17. Right, boring it with a setting of 4.5, I got 4.48, so I'm not going to disturb that. Alright, now I've got a dilemma which I hadn't really thought about. There's no way for air trapped in there to get out. So I think I might have to go a bit bigger, so it isn't such a firm fit, because I don't think I can press that all the way in there. That air's got nowhere to go. One more pass. So I think this is the fit I'm looking for. No movement there, and I think that's just loose enough to leave room for a dot of Loctite. So it's just dry fitted at the moment. Let's see if we can see any run out. Well, as my dad used to say, a blind man would be very happy to see any run out there. This piece of stock is destined to be the extension housing, which will be screw fixed to the back of the cam box. It'll have a hole in the middle for the extended camshaft to pass through, but it's a clearance hole. So it's a pretty simple operation. I've got to turn the OD to 24mm and then turn a spigot, which will be the spigot upon which the timing disc cover sits. So first up anyway, let's get 8mm or so, or 10mm or so, of OD at 24mm diameter. Hopefully that's somewhere near 24. So now I have to turn the stub, which is 6mm long and 10 diameter. We're aiming for 10, so we'll start slowing down a bit now. I think we'll do 1mm depth of cut here, so we'll go for 12. Amazing. Alright, so I guess we can shoot for 10. Right, well, let's see how close we landed to 10. Oh, undershot by 0.003. Oh, never mind. So that 10mm diameter will fit in a 10mm hole, and in fact that's the 3D printed part. Yep, so I think that's going to be hunky-dory. So the only operation left to do on the lathe now at this point is drilling the clearance hole through for 5mm. And just wondering whether just using the drill and accepting that it's going to go slightly oversized gives me what I want without any messing around. Actually, I probably would rather have that as a correct size hole in the first instance and then open it out a bit afterwards, because I'll use it as a locating feature when I set the bolt pattern through this. Yeah, okay, so that's what we'll do. Aim for 5. Alright, see if we can get this in at 10mm. That's my 5mm drill shank, and that's slightly undersized, so that reamer has gone undersized. That's another 5. Let's try this guy. Well, it took some material out, so maybe it's done the business. Cover your eyes. See if that's opened it up a little bit. Oh, nice. Yep. That's a good location fit. Yep, happy with that. Right, so for the moment, we've just got to get rid of the burrs on the corners. Well, this one, yeah. Did that very nicely. Yeah, very good. Yeah, that's fine. Alright, so it's out of the lathe, and actually, let's think this thing through. In my original design, I had flat or square sides, straight sides, and I needed to have something to get hold of it by when I was drilling the holes. But now I'm leaving it fully round. I can grab hold of it from that side and drill the holes. So I reckon I can actually part this off while it's in this setup. Yeah, I think that's what we'll do. So I think the next thing I'm going to do is drill the hole pattern in the back of the cam box. So that's going to start by finding the centre of the bearing and using that as the datum for the work to do on the back. So the bearing has an 8mm bore. I've got an 8mm pin here, which is a good sliding fit in that bearing. And after a bit of fiddling around with the edge finder and other things, I'm satisfied that the bearing is centred under that. To maximise the chance of success here, success being measured with the concentricity of my drilled hole with the centre of the bearing, that's a spare bearing. I've machined up a guide bush, which is a nice fit in there, and that's the drill I'm going to use to go through, and then I'll ream it to 5mm from the other side. So see if I can get this bush in the bearing and then start drilling the hole. Showtime. Bit of an anticlimax, eh? It looks like it all went smoothly though. I just fished that bush out. There it is. I think it did its job perfectly. Well, I think I got a pretty good result there. So I've got my extension piece pushed in through the hole in the case, and it lines up well enough that it all turns quite easily. So, quite pleased with that. That's a 5mm shaft in a 5mm reamed hole. It doesn't run completely freely, it's touching somewhere, but that's not going to matter because I will be opening that hole up a little bit. It's supposed to be a clearance hole anyway, but for the moment it's just being used for alignment. So now I have to drill 4 holes through the cover and into the box. Drill and tap for M2.5. Can't see whether my chuck jaws are about to hit that. They will. See if I can let some more of the drill out. Alright, well, I'll have to drill the holes I think, and then come back and finish them out. A bit of countersink the 2 at the front here. And countersinking these holes, I've got to sneak up on this tiny bloody countersink. That's going to be pretty close, but possibly still more. Anyway, that was 1.1. So I solved my drill reach problem when I remembered that I had a long series 2mm drill. I know I didn't think of that before. Anyway, so and I've decided I will drill right through to make sure I've got room for the end of the tap. Yeah, so we'll just go out the bottom now. Alright, now I know for sure that the countersunk isn't deep enough. I was worried before in case the screw had bottomed in the hole, but clearly that's not the case. The countersink needs to be bigger. But I think rather than using a countersinking bit, I'll use a 5mm drill, because that head diameter is 4.9. So I did some experimentation on a piece of scrap and found that I got the countersink effect that I wanted by just counter boring the tapped hole with a 5mm drill for 2.2 millimeters deep, and that got me what I wanted. So this is the lucky last. Need to go and get a screw. I tipped 4 out of the bag earlier on and then promptly dropped one down there in Narnia somewhere, I suppose. Yeah, I've just got to probably face that off a bit round where those drills left a slightly raised edge, but that's good, happy with that. Right, so that's the cambox extension installed, and you see now the camshaft spins quite freely, so happy about that. So next up, This is the housing for the timing disc. That's going to go on like that. So that's the next task. Make this thing out of aluminium somehow. So we'll turn a piece down to the maximum outer dimension of this bit I'm trying to make. Should be somewhere near 29. Yeah, that's close enough. So this thing ultimately has a hole that goes right through that's 10mm. So I'm going to start off with a 9.5mm drill. Alright, well we'll shoot for 11 this time and see how that goes. Might be a bit closer this time. Pretty much on 11, so that's good. We'll press on now. Did that quite easily. That was with 1mm off the diameter. Now, since I've got quite a lot of material to take out, I'll have a go at taking 2mm off the diameter. And quite a bit of spring on that, because this isn't a very big bar. But in fact you can see perhaps that there's a groove when I pulled it back out. So quite a bit of spring on that. So just checking whether I can get a bigger bar in. No, I need to take another cut first with this little fella. So we're pretty much right on 20, that's great. This bore is just to give clearance to a 20mm disc, so 21 in that sense is a bit nominal. Yeah, anyway, so we'll go for 21 on this shot. And let's see how close we got to 21. It's always like unwrapping Christmas presents, this, you know, see what sort of a surprise you're going to get. So 21. Well, we're 0.005 under that. So that's good enough. For sure, that's good enough. So a little bit of deburring, I think. So now I think it's time to ream the hole at the bottom out to correct size. So I've opened the hole in the bottom to 10mm, and this is a 10mm dowel pin, and I think you can see it's not the air trapped in the hole is pushing it back out, so it's actually a pretty good fit. That's what we want. So I can part this guy off now. Over to the milling machine now. So I have my workpiece mounted in the 3-jaw on the rotary table now, and I've got it dialed in. I did that using the jack screws, and I've mentioned this in a previous video. I'll put a link in the remarks to it, but as I think you'll see, it's let me get this dialed in pretty well. So I'm within 0.01, that's probably the limitation of the accuracy of this method. If I could be bothered to stick a DTI on it, I might get a more consistent result. Anyway, I'm happy with that. So getting ready now to mill the shape into this piece. So to be clear, what I'm trying to do now is reduce the diameter around a lot of the circumference of this thing, but leave a pad behind. This piece is actually located on this stub shaft. When I made the stub shaft up, I left a 10mm spigot on the end, which locates in the 10mm hole on the back of this, so it's quite accurately located. Then there's a bolt down through the guts holding it all together. And because I was a bit worried about this end mill unwinding this, I Loctited the bolt in last night. So I don't know how much trouble it's going to be getting the bolt out, but it should stop this thing from turning. So now this is 29 diameter, that's 25 diameter, so obviously I would go in about 2.5 radially, but I want to give the cutter an easy life, so I think I'll come at half the height first with the depth of cut of 1mm, and we'll see how that goes. Well, that's encouraging. My shape is emerging. I'll go back to the start. So I guess we can come down to full depth now. Alright, there's still plenty of opportunity for messing it up, but we're off to a good start. So my second pass, I'll go to almost the full depth. Right, round to start position. Now this time the start position isn't going to be 41. It'll be 40 and 45 minutes. It was 0.75 of a degree. And this time we will come down to just past that, which is say 21. I'm a bit nervous now. Alright, well, let's fingers crossed, let's hope we can finish this off without ballsing it up. So down to 21. That's actually looking pretty good. So what I have to do now is put a flat across here because I've got to drill a 10mm hole that way. So I think what we'll do is bring this back to the 0 position, which should mean that we're on the centre line of that face. Right, we'll come down to full depth of 20, 21. Well, actually we don't have to come down that far, we've only got to come down to that, so 15 will do that, and then I'll take a light shaving off it. That took off far more than I was expecting it to, but that's okay, we're not in trouble. No, maybe that isn't the best camera angle. Let's come back round here. Alright, I think you'll be able to see though that we've got a flat pad now which doesn't go quite to the outside, so I've got to go a bit deeper. Oh, that looks nice. We've just got a slight chamfer just on the very corner. That's pretty good. Okay, change the setup so I can drill my hole into that face. Alright, so as you see, I've rotated the rotary table setup 90 degrees and used a dial gauge to line up on that top face and ready to punch my hole through. Now there's a bolt head just underneath there, so I think what I'm going to do is a pilot hole and then follow it up using this guy as a 10mm slot drill, but just so I can punch through and don't have to go through very far and hit that bolt head. Actually, I just remembered it's a 12mm hole I need there because the piece that goes in there has got to have a 10mm bore. So it didn't leave much meat around the hole, but that's what I expected, about 1mm. Right, so I've transferred this beast over to the lathe because it's got a much better gripping power. I've put it in low back gear. Let's see if we can get this bolt undone. Oh, the Loctite did its job perfectly. Yeah, that's what I used. Give me a thumb out of the way, Ella. 248. It's formulated as a bit of a paste, I suppose, so you can use it overhead. Well, that wasn't relevant here, but anyway, they call it their sort of medium strength, and I'd say that was just about spot on for what I was doing. I was worried I was going to have to get the torch out. Clean up time. Oh, you can see now too the spigot I made, which was a tight fit in the back end of that thing. So moving on now to make the little chimney, or a little tube, that's to go in that hole. Now it's a little bit tricky, like all these little bits are. If you have a quick look at the drawing, yeah, there'll be a radius on the end of that little tube, so when it sticks into that bore, it follows the side wall of the bore. Yeah, well, we'll see about that. So anyway, here's my piece of stock that I'm going to use for the tube, and I thought what I'd try to do first is use this end mill. Strictly I should use 21mm diameter or 10.5 radius, but this is 20 and I think that's going to be close enough for my purposes. So I'm going to form that radius first, because when I finish boring and turning it's going to be very thin walled, and I don't know how well it would work out trying to put that profile on it across the thin walled tube. Anyway, we'll see how this goes. I was originally going to use the boring head to do this, but I got lazy and realised I could get pretty close like that. That's a bit over 12 now, so that should be good enough. For an experiment, I think we'll take it over to the lathe and see how it works out. Right, I think I'll start this by just doing the outside diameters and see what that looks like in the piece. And if it looks good, then I'll come back and bore the hole. The outside diameter, major outside diameter, is 14mm plus or minus 0.1 or something, so no particular accuracy required there. So that should have fetched up pretty close to 14. I always get amused when that happens, especially when it doesn't matter, as in this case. Anyway, so that's that. Now I've got to do about 4.5 at 12. So this dimension is to match the bore, and I'm going to Loctite this piece in. So it doesn't want to be a press fit, because there really isn't enough material to support a press fit, and it needs to leave a little bit of room for Loctite. Clock it roughly correctly before we start. And that's a darn tight fit. I reckon I might just leave it alone. Oh, I've got to bore the hole. So we've got 8mm drill here. We're going 15, I think. Then we'll bore that out to 10. That should be somewhere pretty close to 10. Actually, this is another one that's not crucial, because I'll be 3D printing an insert to go in here, so that'll be nominally 10. But still. Yep. What's left to do is turn down the back side here a little bit. This is aesthetics. This bit serves no functional purpose. I'm very short on right-hand turning tools. It's not something I've needed to do much of, but I think I should lash out, and I only have one basically, which is this guy. It's a pretty good tool, but it can't get in close. It's just too big. This guy here is a bit of a multi-purpose. He can do it. Right, let's get this thing finished off. Alright, well that turned out alright. It's got a bit of swarf or tag to clean off there. Then we're done. Of course, there is one thing I didn't think of. I I'm not sure how I'm going to be able to clock this thing when I push it in the hole, because there won't be much to get hold of. We'll worry about that when we get there. So with the timing cover basically finished, I moved on to making the timing disc. It's probably got it started well enough that I can get hold of it with something now. The body of this thing is a pretty simple operation. It's basically a plain disc, outside diameter 20mm, ID 5 and thickness 5. And it needs a clamping screw to secure it to the camshaft and a hole in the face for an embedded magnet. So it's a pretty simple bit of kit. But a bit of thought went into how to hold the disc for doing these operations, and I made up another arbor with a locating spigot and fixing screw. So I started on the mill with the rotary table in its vertical orientation and set it square to the mill table. This meant that the arbor was mounted horizontally and in line with the y-axis. So the disc's now vertical and can receive a radial hole into the edge. And that hole is going to be tapped, or in fact you see me tapping it here, to hold a 3mm grub screw. That's so that the disc can be clamped to the camshaft. I used the edge finder to position the disc under the quill and did the business for that M3 tapped hole. I think I'll finish tapping that when the disc is off and I can see the tap come out the bottom. That finished the work that needs to be done radially. So now I've got to turn this whole lot over 90 degrees so that face is pointing at the drill chuck. But the hole for the magnet has to be drilled axially, that's to say into the face of the disc. Good news though is that the two holes are in the same XZ plane. This meant that I was able to just tilt the rotary table over onto its horizontal orientation. It's important to note that before doing that though, I locked the rotary table so it couldn't rotate, which would cause movement along the y-axis. So anyway, then when I set the rotary table square to the mill table again, the first hole was kept in its original plane. So then I went through another round of centre finding on the now horizontal disc, and after that the magnet hole was a simple offset away from this new origin. So I'm getting ready now to drill the hole to mount the magnet, and I think I'm waffling on here about the practicalities of doing this. So I drilled a test hole in a piece of aluminium, and because I know these magnets are actually quite brittle, and I wanted to see whether it was actually possible to drill an appropriate size hole in aluminium so you could very lightly press the magnet in without getting involved with adhesives and such. But I decided that that was not a valid option, that it needed to be really quite a loose fit, and so we'll probably need super glue in it anyway. So I gave that idea away. So as a result of my experiments, I decided that the best thing was just going to be to drill and ream a hole to the exact size of the magnet and use a super glue or some such to do it permanently. So anyway, the magnet is 1/8 diameter, or 3.18mm. So I drilled and reamed that size hole, and that made the magnet a very light push fit into the hole. And I thought, well, that's going to be good enough. I'll put super glue on it when I'm doing final assembly. So with that hole drilled and reamed to size, I figured, okay, well, it's time to take the disc off and try and fit the magnet to it. And as it comes off, by the way, you can see that spigot that I was talking about that was locating the thing. So after I took that off, I realised that that was actually going to give me a fairly easy way to install this magnet, because they're fiddly little things. So I put it back on. I just knocked up this little arbor with a driver point. So let's see how that goes. Suddenly decided to jump through. Oh well, it's in there. Well, there's the magnet. It's fairly firm in there. I don't know that it's firm enough that I'd trust it with the running engine, but it'll do for now. And after I've set the ignition up and seen that everything's all right, then I'll glue it in. But for the moment, that's going to be good enough. So I think that means this disc is done. Magnets in, locking screws on, that's it. So fixing mistakes time again. This little fella is supposed to have a groove around there so that the clamp screw for the timing disc engages in that groove, and that will do two things. It will stop the timing disc from falling off, but it also stop it from damaging the surface that we turn it on for adjustment. Anyway, so I've knocked up this simple one-purpose chuck. So it's just a recess that matches the diameter of this and a threaded hole. It's a pretty close fit. And a retaining screw. And I don't think that'll have too much trouble resisting the force that this parting tool is going to impart to it. I'm not going to go any deeper. You'll get the job done. Just well, in any case, I'll have to find or make a dog point screw. But yeah, so we'll call that it as far as it doesn't show up very well, does it? Belatedly, that's a bit better, I suppose. You can see the groove a bit more clearly. And while I had this disc mounted in the lathe, I cleaned this face up to get the raised ridges around the holes out the way. Yeah, so you can see that cleared out. All those ridges around the holes have been wiped off. So now I have to drill a couple more holes in this housing. This one will be to give access to the grub screw in the timing disc. Right, so that hole only needed to be big enough for the Allen key for the grub screw. It's not very big, so I've drilled it 2.5. That should be okay. So the next hole in the housing is to engage in that groove and to clamp the housing around that piece. So this tapped hole will be for a thumb screw that will be accessible with the engines running, so that we can actually rotate effectively the distributor, although it's only a single cylinder. And I've tried to line it up so that this will be roughly the final position, I'm hoping, of the sensor. So this will just be sitting roughly on top. That's the plan. Anyway, I can drill in 7 here before I hit the what's the thing called? Spigot, that's what it's called, the locating spigot. Right, should hit the locating spigot, and so now I can start tapping. I won't be able to finish the tapping, obviously. I have to take this thing off to do that. Right, I should get this started without any dramas. Hand's going to get in the way here. And finish tapping that hole with something a bit more subtle. Right, well, I think and that's a pretty good start on that thread, so we'll take this out and finish it in the vise. I want to fit the pulley to the camshaft using a keyless hub. Couldn't buy a correct size pulley with that hub, so I'm going to scavenge one from this and bore my pulley out to take it. My pulley had an 8mm bore, and I need to take that out to 18mm to suit this keyless hub. So I needed to start out with a relatively small diameter boring bar, which only wanted to take light cuts and was talking quite a lot about it. But once I got out to 16mm, I could switch over to a much larger bar, or a 12mm diameter bar anyway, and that gave a much more satisfactory response. I don't know how much these things can take up. I'm guessing they need to be pretty much right on size. We go with 17.98. About 9.9, or maybe almost right on size. Right, well, let's try the hub. get rid of the burr around the edge. That might be all that's stopping me at the moment. It wants to go in, just not quite. I might run the cutter through again. Well, that's a disaster. That's because there wasn't enough clamping force and the scroll chuck came undone. Well, you got to be lucky sometimes. I just marked that bore. It's at 17.99, and this just would go in, and can still get the axle in. So that actually has turned out to be pretty much a perfect fit. So that was a disaster avoided by sheer luck. So I've got the Hall effect mechanism properly sorted now, and the pulley with the keyless hub, and I don't know how well that shows up. I'll just turn the lights off, make it easier to see. So that shows up a bit better. So when I spin this, you will interestingly only see intermittent flashes. That's because I can tell you it's flashing continuously when it's spinning. But what's going on is some of the flashes are being lost between my 60 frames per second camera collection rate and your screen refresh rate. It's an interesting phenomena. Anyway, so let's turn it around and have a look at the back. I'll just turn the lights back on. So we're looking down inside the housing, and the magnet's about 12 o'clock at the moment. Coming round to 3 o'clock and then triggering the light, which does just show up. The two extra holes that you see in the face of the disc so that I can get hold of it with these to remove and position it. Just made it easier. Alright, so I think that turned out quite neatly. So I'm calling the housing that I've made for this Hall effect sensor a done job. So it was quite a bit of work to produce this way of doing it, but I'm quite pleased. I think it's a very neat solution and quite in keeping with the appearance of the rest of the machine. So I think in the next episode I'll be doing final assembly, setting valve clearances, ignition timing, all of those sorts of things, and daring to hope that I might actually get the engine to run. But in any case, thanks for watching this one, and I look forward to seeing you on the next one. Cheers.